Welcome to my ENME351 final project, the Automatic Guitar Tuner. The way I formatted this video is I'll be showing the full tuning process start to finish in the corner while I go over the circuit, Arduino, and processing. Now before I go under the hood of my project, I wanted to clearly show what it does. First, turn on the Arduino, processing, and servo power. Then, choose which string to tune with an off-screen potentiometer, and finally, start playing the string while holding the servo firmly over the tuning peg. This should get the string in tune plus or minus 1 Hz in about 2 to 4 seconds depending on how out of tune it initially was. The processing is simple, but designed to emulate a commercial instrument tuner. Apart from using the serial code used in many labs to import the Arduino output, notable details include conditionals to change the text color depending on how in tune the guitar is, as well as to change the location of the illuminated tuning scale boxes. There are 4 major components in my circuit: the Arduino, the breadboard containing a potentiometer used as a 6-position switch and a microphone for guitar input, and then we have a AA battery holder for servo power and the servo itself. Here you can see the Arduino pins used. There's 5 volts and ground to power the smaller components on the board, a gray analog 0 for microphone input, a blue analog 1 for potentiometer input, and another gray for the digital 2 servo PWM signal. Now the servo itself is controlled by a switch on the battery holder. When you want to stop tuning, just flip the switch off. Finally, you have your potentiometer wiring, your servo power, and your microphone, which is just 5 volts, ground, and a gray V out that's covered up. The Arduino, on the other hand, is complex. While the first block and setup method is mostly initializing global variables, importing libraries, and assigning pins, the loop, get frequency, and string tuning methods are about a couple hundred lines of conditional logic. The loop method calls the get frequency method to find the peak frequency at that instant, and also reads potentiometer voltages and uses 6 value windows to let the user choose which string they're tuning at that moment. Each tune method takes the instantaneous FFT peak frequency, applies a correction factor that assumes linear sensor error, divides frequencies in certain windows in order to sample harmonics, and finally, if statements to determine the servo speed and direction needed to tune the string. Last is the get frequency method, but since the math and code is baked into a library, instead I'll talk about sampling and harmonics. Since sampling frequency is based off the highest open string, you technically only need to sample at 2 times the Nyquist frequency of E4 to avoid aliasing. However, I found that to get any real accuracy, you need to sample and divide harmonics data as well, which bumps the max up to 2 times 510 Hz. But anyways, let's hear what the intro really sounds like.